We begin Math 99 by reviewing some concepts from Chapter 1. In Section 1.1, we want to pay attention to solving equations. In equation solving procedure, you clear the equation of fractions if needed, simplify both sides of the equation, get all terms with the variable on one side of the equation and all other terms on the other side, and then isolate the variable. Let's solve three examples. Our first problem will be 6x plus 5 minus 7x equals 10 minus 4x plus 3. So we want to combine like terms. 6x minus 7x will give us minus x. And on the right-hand side, 10 plus 3 gives us 13 minus 4x. I like to get rid of the x term that is the smallest. So minus 4x is smaller than minus x. So we add 4x to both sides. That will give us 3x plus 5 equals 13. We now need to isolate the x. We do that by getting rid of the 5 first and then the 3. So we eliminate the 5. The opposite of plus 5 is minus 5. We subtract 5 from both sides, and that gives us 3x equals 8. Now we need to eliminate the 3. It's 3 times x. The opposite of multiplication is division. We divide both sides by 3, and we get x equals 8/3. We can check this solution by substituting it into the original equation, and we will see that it makes a true statement. Our second problem, we have parentheses. We need to eliminate the parentheses by using the distributive property. We pay special attention to the minus 5 times x plus 5 here. So it's a negative 5 times x, which gives us minus 5x, and it's a negative 5 times a positive 5, which gives us minus 25. Make sure you realize that that negative 5 is being multiplied times the positive x to give us minus 25. On the right-hand side, we have 3x minus 6 minus 1. So now we combine like terms. 2 minus 25 is minus 23 on the left. On the right, minus 6 minus 1 is minus 7. So we need to eliminate the x term. I like to eliminate the smallest one. Add 5x to both sides. Why not go ahead and add 7 to both sides too, so we get the x term isolated over here on the right. That'll give us 8x, and we'll have minus 16 on the left. Now we need to isolate the x. We need to get rid of that 8 times x. We divide both sides by 8, and we have negative 2 equals x. Once again, we can check that solution by substituting it into the original equation. Our third example, we first eliminate the parentheses, and we have 4x plus 8. We combine like terms. 3x plus 4x is 7x. Now we subtract 7x from both sides. But look what happens when you subtract 7x from both sides. You get 8 equals 11. That's not true. That's never true. There is no solution to this equation. So when you end up with something such as 8 equals 11 or something involving two numbers that is not true, you know that you have no solution. Section 1.4, Inequalities and Interval Notation. The graph of an inequality is a drawing that represents its solution. Let's graph first. X is less than 2. We want to start at the number 2. We're looking for numbers that are less than 2. 1 is smaller than 2, less than 2, 0, negative 1. So we use a hollow circle on our graph to show that we do not include 2. It is not included in the solution. And we shade to the left to show that those are all numbers less than 2. Our second graph is x is greater than or equal to 1. We want to include the 1, so we use a solid circle to show that 1 is included as part of the solution. X is greater than 1, so we want to shade all numbers to the right. Graph negative 3 is less than or equal to x is less than 0. X is between negative 3 and 0. It can include negative 3, so we use a solid circle. It cannot include 0, so we use a hollow circle. Another way to write solutions of inequalities in one variable is to use interval notation. If you want to know more about that, we're using parentheses and square brackets. You can see page 114, 115 in your textbook. So let's do these graphs above with interval notation. Now, parentheses show that the endpoint is not included. We want to start on the left as far as we can go. That would be negative infinity. Negative infinity, however, is the concept of the smallest negative number that we can possibly have. So we want to keep going to the left as far as possible. We're never going to get there. Negative infinity is a concept. It's an idea. So you cannot include positive or negative infinity. We use parentheses whenever we have positive or negative infinity. We do not want to include the two. We showed that in the graph with a hollow circle. We show that in interval notation with parentheses. Our next graph, we included the 1. We will use square brackets in interval notation to show that the 1 is included. We keep going to the right as far as possible until we get to positive infinity, and we use parentheses whenever we include or whenever we use positive or negative infinity. Here we have a square bracket to show that the negative 3 is included. The 0 has a parenthesis to show that it is not included. We want to solve inequalities. We solve inequalities really very similarly to the way we solved equalities. The only difference is whenever we multiply or divide by a negative number, we must reverse the direction of the inequality. Our first problem, we combine like terms. 2y minus 9y, we get negative 7y is greater than 7. Divide both sides by a negative 7. You should have an alarm bell that goes off whenever you divide by a negative number so that you know that the direction of the inequality must reverse. It becomes y is less than negative 1. Our second example, we subtract 2x from both sides. Why not go ahead and subtract 1 from both sides? That'll give us the x isolated by itself on the left-hand side. X is less than or equal to negative 4. Eliminate the parentheses using the distributive property. 2 times 3 is 6. 2 times the negative 4m is negative 8m. Minus 9 is greater than or equal to 45. We need to combine like terms. 6 minus 9, that gives us a minus 3. Then we're isolating the m. We add 3 to both sides. We have negative 8m is greater than or equal to 48. We do not want that negative 8 there multiplied times the m, so we can eliminate it by doing the opposite, dividing by negative 8. When you divide by a negative number, you must reverse the direction of the inequality. So our solution becomes m is less than or equal to negative 8. That's all for section 1.1 and 1.4. Check a new tape for section 1.5.